Let's say, in light of recent events, you decide to take a test for the COVID virus, which is accurate around 90% of the time. The doctor hands back your test results, and unfortunately, you tested positive.
Now, this is terrible news for sure, but how concerned should you actually be? Well, it actually depends. While many people only take into account the accuracy of the test, the infection rate of the local population also matters. Imagine a population where 1% is actually infected with the virus. Turns out, the chances of you carrying the virus when you test positive is only 8%.
This percentage might surprise you, but let's check how it's actually calculated.
In a group of 1,000 people, if 1% were actually infected, then around 10 people are carriers of the virus, with the other 990 being non-carriers. When the doctor says that the tests are 90% accurate, let's assume that would mean 10% of people who do not carry the virus would test positive, and that 10% of people who do would test negative. Thus, 99 of the 990 non-carriers would falsely test positive, and 9 of the 10 infected would correctly test positive. The probability of you being the 9 out of the 108 total positive testers would be approximately 8%. Sorcery, huh?
All of this can be summed up with a simple but omnipotent mathematical theorem called Bayes' theorem.
The theorem states that the probability of event A happening if event B happens is equal to the probability of B happening if A happens, times the probability of A over the probability of B. Bayes' theorem has a wide variety of applications, ranging from medicine to finance to even treasure hunting.
Let's approach the same problem with the same accuracy of tests, but this time, let's increase the total infected percentage to 10%.
Using Bayes' theorem, let's calculate the probability of you being actually infected if tested positive. Let P of A be the probability of being infected, and P of B be the probability of testing positive. P of A would be 10%, and P of B given A would be 90%. The probability of testing positive, P of B, is calculated by adding two parts. The first part is a product of P of B given A and P of A. The second part is a product of P of B given not A and P of not A. Calculating all of this, the probability of you actually being infected with the virus while testing positive would be 50%. As you can see, this is much higher, and therefore you should be much more concerned. Regardless, you should still take a second test to confirm the results.
Math is behind everything in the world around us, on happy days or in difficult times. Stay safe and healthy, and thanks for watching.